my party people, let's go ahead and take a nice little picture here. I'm going to go ahead and zoom on in just a little bit. Let me zoom on in just a little bit there. That way my iPhone people or my Android people who are using their phones can see this a little better. So everybody, let me go ahead and teach you a little bit about distance, rate, time. And before I do, let me go ahead and just move this away. I know some of us are taking notes. I just want your attention. So on a scale of, scared, not confident, neutral, kind of confident, and feeling amazing. So again, from that little spectrum there, from I'm scared of it, not confident, I'm so-so, to confident, to I'm feeling amazing. Where are you right now when it comes to distance, rate, time overall? Like your ability to understand it, to point it out in word problems, to be able to calculate and go backwards to find the time or the rate, like all of that. How are we feeling when it comes to all of that? Are you able to actually explain it and not just do it? Like that's really my big question. Need to refresh, feeling neutral. I saw a lot of no's before, feeling scared, and that's okay. It's a nightmare. Feeling lost, a lot of question marks, need a refresher, feeling okay, amazing, I don't know, neutral. Okay, cool. So here's the thing. Who here has seen my 5 steps to learning video? So yes or no, who here has seen my 5 steps to learning video? Okay, so I see that a lot of you guys have, because a lot of you are in my program that are here. That's great. Now, for those of you that are not in the program or have not even seen this video, let me go and just hook you guys up. No problem here. So check this link out in the chat box. I'm going to go ahead and post this. Okay, cool. So I just shut down the text chat real quick. There's a link in the chat box. It's called the 5 steps to learning. It's my YouTube video there. Long story short, if you ever have been struggling and been frustrated with really not knowing when you're good to move on from one topic to another, and then you move on, and then a couple of days later, you completely forgot that topic. If you've ever been there before, then this video is going to be one of the first steps to take to really fixing that. So again, if you've ever had issues with learning a topic one day and then forgetting it in 2 days, this video is for you. It's the 5 steps to learning. It takes you through the process at which you'll know that you're good to move on. So there it is. Let me open the chat back up. I'm being very serious when I say that everybody here should be watching that video no matter what. So with that said, why did I just say that? Why did I just share that video? The reason I just shared that video is because when it comes to distance, rate, time, it is not just about memorizing a formula. That is honestly step A.1.1.1.1.1. Like there is all the other step A's and B's and C's and D's, but memorization is honestly like just picking up the pencil. It's not actually doing the work. It's just having something to write with. And so to understand where to pick these things apart in word problems, to understand how to actually point them out, how to plug them in, and how to know to check your work and know that you're right, that's really what we should be aiming for. And basically, at the end of the day, what that means is being able to explain what you're doing. So that's the goal here. So distance, let's start there. Everybody, yes or no, do you identify distance as something like feet, inches, miles, kilometers, meters, centimeters? Is that fair to say? I've been teaching for over 10 years, and I got a master's degree in math education, which is my specialty, but I also teach English and general science as well. At the end of the day, I want to make sure that you can stress less and not have to worry about having anxieties about the test, being able to actually not blank out and feel confident about what you're doing. And at the end of the day, are you able to study consistently and know that you are growing? That's really what matters to me the most at the end of the day. So that's why my program is here for you to help you succeed. It has everything you need: the classes, all the recordings, all the practice you'll need, and the ability to text me directly so you have your coach with you, mentoring you every step of the way until you pass. I'm serious about your success. So go ahead and click the link in the description of this video or somewhere over here. That way you can watch how it works, see all the details, and sign up and start raising your score right away. If you have any questions, my phone number is 567-698-8867. Again, I'm Coach Anderson. Text me and ask me about the program, or click the link and watch how it works. Let's get this done. Let's raise your score and get you that job you deserve. Let's get to it. All right, cool. So here's the thing. that's only one part of distance, or of what defines distance. So that's right over here. So let me ask a follow-up question. Everybody, have you guys ever seen a word problem for an ASVAB practice? Something along the lines of, oh, we have Jimbo over here who's filling a pool up with water at a rate of about 14 gallons per minute. How long will it take to fill up the pool? Who's ever seen a problem like that or heard of one like that? Well, guess what? That's a distance, rate, time problem. Did you know that? That right there is a distance, rate, time problem. Yes or no, did you know that? Filling a pool up with water is a distance, rate, time word problem. It is. I'll give you another example. So anybody ever seen the problem where there's someone reading a book, and little Jimmy over here is able to, I don't know why I'm fixated with Jimmy today, but whatever. So we have little Jimmy over here who is able to read 3 pages every 3 pages an hour. If the book is 419 pages long, how long will it take Jimmy over here to finish the book? Who here has heard of those problems before? Just today. So here's the thing. That is also distance, rate, time. And so this is where I start kind of needing to address what the heck actually distance is. Like, this is the conversation we need to have. What really is distance? So that's the big question right here. And let me make it very clear for you. The distance is the amount that you're trying to accomplish. Okay, that's what distance is. Distance is any amount that you are trying to accomplish. So most familiarly, y'all are used to seeing it as, oh yeah, how long will it take to bike those 22 miles? Or how long will it take to for the train to go 172 miles and things like that? We're used to that, right? So don't worry, that's not going to change. But I need you to understand that distance, again, is not just distance. It is also amounts and money. Money is also considered distance. Here's another example. Everybody who here, yes or no, has heard of the example where you're talking about saving money. We're talking about, let's go ahead and say Wade. Wade over here is earning $18 an hour at his job. God bless him. And he wants to save $1,200 to put a down payment for a new bike. How long will it take Wade over here to get the $1,200? Who here has heard of that? That is also distance, rate, time. That is also distance, rate, time. So here's the thing, everybody. Any distance is considered any amount that you're trying to accomplish. If you're trying to achieve something, a certain number of miles, books, money, whatever it is, that's distance. Let's talk a little bit more about rate, because this is the hardest thing for a lot of people to be able to identify. So if you're noticing, I'm taking my time going through these notes, but notice how I'm talking about the notes. I'm talking about it in a way that allows you to speak about it in English. Notice I'm not throwing around words like, oh yeah, this is a derivative unit. No, just talk about it in English here. What is a rate? Is everybody here in agreement that if I were to say rate and speed are pretty much the same thing? Would you guys agree with me if I said that? Rate and speed are pretty much the same thing. Right on. Cool. I'm glad you guys agree, because I want you to agree with me here. Now, are rate and speed the same thing in every single topic and every math course you'll ever do? Absolutely not. But for the purpose of taking the ASVAB, let's keep it simple. They are. Rate and speed are the same thing. Now, let me go ahead and forward the story here. Speed. What's speed? Speed is pretty much how quickly something's happening. Typically, we think speed as miles per hour, right? Typically. Or if you're from anywhere from, but the US, kilometers per hour. Cool. But here's the thing. Speed, again, it's the rate. It's how quickly you are accomplishing the distance. So for example, if you're trying to make money like $1,000, well, then a rate would sound like dollars per hour. That's how much you get paid at your job. If you think about an actual distance, miles per hour, kilometers per hour. If we're talking about the book example, we could say pages per minute. pages per hour, books per year, right? Those are all different rate units. Now, everybody, between all of that, miles per hour, kilometers per hour, teddy bears per day at a factory, pages per minute, words per minute, between all of that, what's the common theme between all of that? What is the common theme between all of those things I just said? Time was definitely one of them, but the bigger word here is per. Yeah, right over here. I went pointing the other way. But yeah, it's per. It is going to be per. Now, here's what the word per does. It pretty much combines two units. It combines your distance and it combines the time to tell you how quickly you're achieving that distance over time. That's what rate is, how quickly you're achieving that distance over time. So with that said, again, rates can be considered anything with that word per right there. Typically, you'll have time on the other end of it, like month or minute or hour. And to keep it simple, you can expect time every single time. Every single time, you can expect it. Everybody, before I move on, yes or no, are we good? Are we good with that piece of English right there? All right, great, sounds good. So with that, let's go ahead and look at time. Again, time is just literally how long it takes to achieve that distance. That's all time is. You know, how long does it take? So with that said, let's go ahead and move on here. Now, when it comes to distance, rate, time, again, you got multiple objects. This is what we're dealing with today. So remember, if you're going to be joining us tomorrow, we're going to be doing single object distance, rate, time tomorrow. Today, we're doing multi-object, where you have two or more objects here. By objects, that means people, cars, planes, trains, whatever it is. So here's the thing. Again, some of these examples, here they are. Two cars driving away from each other, a plane trying to catch up to another one, two boats on a collision course. All of these, again, would be good examples. So here are the rules. Go ahead and write these down. Go ahead and thank Coach Sheena and Emma for working on recreating these slides for me. So I appreciate them. So here we go. When the objects move at the same time, I can't stress this enough right here. When the objects move at the same time, write that down. Please do yourself that favor. If they move at different times, you have to figure out a point at which they're both moving at the same time. So again, you have to figure out the point at which they're moving at the same time. If the problem doesn't give it to you that way. Typically it does, sometimes it won't. So here we go. If the objects face opposite directions, you will add the rates. And the reason is because they are covering ground together. So if the objects are basically looking away from each other, like right here, basically the distance covered this way and the distance covered that way, they're different. They're different. So you're basically adding those distances together, this way and this way. Same thing if you're going toward each other. From here to here and here to here, they still have not covered the same ground. There's nothing to cancel out. They're actually adding the pieces of ground that they're covering together. So they could be facing each other or facing away. Either way, they are facing opposite directions. So if you're having a little bit of trouble right here, if you're having a little bit of trouble seeing how that's facing each other or facing opposite directions, think of it like this. Just want to make sure I help you out with this one. So if I have this, please help me out. Come on. It's supposed to make an arrow. There we go. So if I do that and I do this, or just kind of give up on life, come on now. There we go. So if I go ahead and take a look right there, everybody, if you're looking at that and you're saying, well, those aren't facing opposite directions. They're facing each other. Well, think of it like this, everybody. If I were to just grab here and move this over here, are they facing opposite directions now? Yeah, they are. They absolutely are. So again, if they're facing each other, they're technically facing opposite directions. This one is facing this way, and that one over there is facing that way. They are facing opposite directions. They absolutely are. Yes or no? Does that make sense, everybody? If the objects are facing each other, They are facing opposite directions. Perfect. That's the biggest thing right there, biggest thing. And then here, if the objects are facing the same direction, zoom on in on that a little bit, right there. So if the objects are facing the same direction, what you want to do is subtract the rates. So here's why. If we're talking right over here, so let's say we're looking at this example, and we're saying, hey, this car is taking off at whatever, 100 miles an hour, and this one's taking off at like 30 miles an hour. How far will the cars be after an hour? Well, after an hour, again, this car over here got over here. But meanwhile, this car has gotten this far. So we need to cover this distance. This is how far apart they are. The distance that they travel together over here, we have to go ahead and cancel that out. We got to cancel that out. Because again, think about it like this. If my right hand, so as you guys would see it, that's my right hand, good. So if my right hand takes 2 steps, but my left hand takes 5 steps, my left hand is only 3 steps ahead, not 5. You have to take away those 2 steps they took together, but then the 3 additional steps is what you're actually counting. That's why you would subtract. Yes or no? Does that make any sort of sense at all? Does that make any sort of sense at all? When you're going in the same direction, you subtract to cancel out the distance that they each cover together. Yeah, because you can't count this right here. You can't count that because they both already traveled. If this is 1, 2, and 3 steps, and this is 2 steps, then they both travel 2 steps together. So you wouldn't count those 2 steps. It's that 3rd step, that extra step that you would count. And that's why you subtract. And don't worry, I'm going to re-explain this for sure a lot. I'm going to re-explain this for sure when we get to these guided practice problems. So don't worry, I'm just trying to make sure that I set up the story first, and then we go through the problems. We're really going to get into it. I got y'all. So let's go through a little guided warm-up here. And in this warm-up, again, the point is not to get the problem or get the answer. The point here is to understand what we're supposed to do. So I want to give everybody here a nice minute, 15 seconds to read the context of the problem and tell me what it is that they think that should be done here. So I'm going to give you a minute. Do not reveal your answer. Do not reveal your answers. Take some time here, read the story, and then you let me know what you believe is going to happen. I'm going to mute myself. That way I can open up a peanut butter and jelly sandwich because I'm hungry. Yeah, remember, just type ready. Don't reveal your answer. Don't reveal your answer. All right, what are our answers? What do we have? Got a lot of A's and B's in there. Got a C in there. Let's see, you got a D there. Okay. All right, cool. Let's talk about it. So what we want to know here is how long will it be until the cars are 150 miles apart? So if you have been to my classes before, or ever watched even one of my YouTube videos, you would know that when I do word problems, the most important thing to do is really read the question first. The question is not really this. This is not really the question. The question is this. What should be done with the 2 rates? So that's what we want to know. So we know that there's going to be 2 rates in this problem. We got to understand what we're supposed to do with them. So if you are here for the first time, remember that one thing that you want to take advantage of is imagery, your ability to visualize and think and really see this. So watch this. two cars start in the same spot and drive away from each other in opposite directions. It's right here. Two cars. Let's go ahead and draw that out. So if we just go ahead and think about it, we have car one over here. I'll just go ahead and draw this like beaten up Taj Mahal looking car, but there it is, cool. And then we have another car right over here. This guy's driving an old Cadillac. All right, cool and sweet. So we have two cars start in the same spot and drive away from each other in opposite directions. So everybody, what's the key phrase right there? Drive away, opposite directions. Right there. Drive away in opposite directions. And so when we check out their paths, we have one car going this way. We got one car going that way. Everybody, what did we say that we should do when it comes to two objects interacting, going in opposite directions? Exactly. We should add. And so a lot of y'all have either by virtue of taking good notes or by memorizing have looked at this and said, yep, adding will be the answer. Now, that's not what I'm after. That is not good enough for me. Absolutely not good enough for me. What is good enough for me is y'all being able to explain why. So everybody go ahead and type into the chat box why you're adding those rates. And don't tell me that they're going in opposite directions. What's the reason that we would add if they're going in opposite directions? Give me the reason in English. In English, what's the reason? I don't need complicated mathematical jargon. I don't want that. I want it in your own words. Why are we adding these rates? Yeah, exactly. They're covering ground together. Exactly. They're covering ground together. The car on the left and the car on the right are covering different ground. Notice this. I can use blue. Starting from the same spot, this car goes this way. This car goes this way. They're not covering the same ground. And so what you would do is you would say, hey, I'm going to add this distance right here with this distance right here. That's how you're going to get to that total 150 miles. Yeah, we're definitely trying to find the time. I know that. I know. But what I want you to first pay attention to is how to recognize what's going on in the story. So we got two objects driving away from each other in opposite directions. And you even have two of the same type of unit here. Everybody help me out. I see that we have 25 miles per hour here. And we have 35 miles per hour there. Everybody help me out. 25 miles per hour and 35 miles per hour. Those are examples of distances, right? I'm just looking at the chat box right now. For those of you who are using AirPods or something and you're at work, don't worry, we're still here. I'm just awkwardly looking at the chat box right now, letting y'all figure this out. So everybody questioned it, or I said this is a distance, and a lot of y'all said yes. So let's go ahead and write that down real quick. 25 miles per hour, is that a distance? This is a rate. This is absolutely a rate. Absolutely a rate. Absolutely. What word gives it away? What word gives away that we're dealing with a rate? The word per. Exactly. The word per is what gives it away. That's the word that gives it away. The word per. 25 miles per hour. So again, remember this right here. This is a distance. This is a time. Per connects the distance and time to make it a rate. Okay? The word per connects the distance and it connects the time to make a rate. Because again, a rate tells you how quickly you're getting to the distance in time. So remember together, boom, it's the word per. So if you have a cat, just go ahead and look at your cat, be like per, speed, cool, do your thing. So with that said, there's the first question here. You tried to trick us. I didn't try, I did. I absolutely did. And I'm going to laugh about it later. So with that, we're going to go ahead and keep moving forward here. And if you guys know me, okay, for those of you that are here for the first time, full disclosure, I'm not that guy. I don't wish malice on anybody. I will joke around with you and I will be sarcastic. So hopefully no one here is a little too sensitive on that. So with that, it's all good, Jalen. So with that, let's go ahead and check out this next guided warm-up. It's literally the same exact question, except we're going to answer it now, okay? Except we're going to answer it now. So let's go ahead and zoom on in just a little more here. Boom, now we can have just a little more room to see things. So the question reads, how long will it be until the cars are 150 miles apart? Again, same exact question that we had before, same exact question. So let's go ahead and check it out here. Everybody, first and foremost, when it says how long will it be, what does that mean that we're looking for? Yeah, time, exactly. This is time. So with that said, right here, we're looking for the time. So blank. Everybody, what unit is the time in this problem listed as? Is it seconds, minutes, hours, days, weeks, years? What is it? Quickly, quickly, quickly. What is it? All right. So if you got nervous for a second or that anxiety kicked in because I started pressuring you really quick, don't worry. I did that on purpose. So my question was, what's the answer supposed to be in? Like, what's the units for the answer? Well, it's right there. The answer key will give it to you. The answer choices give it to you, or the question will too. Either one, they have to give it to you. So you got blank hours. Why is that useful? Well, you need to know what you're solving for. And not only what you're solving for, but in what unit. So with that, let's go ahead here, move forward now. We have some other information. We see that it says 150 miles apart. Everybody, 150 miles, what kind of a unit is that? Mary says G, or Marie, I'm pretty sure that's Marie, said that first. Distance, that is correct. So everybody, well, what did I define as a distance? So this is where I want you to regurgitate it word for word. What did I define as a distance? Is it only inches, centimeters, meters, miles, kilometers? Is it only that? What is my definition of distance for this class today? What did I say? Well, yeah, no, 150 miles is distance, right? But what did I define distance as? The amount that we're trying to accomplish. Who was there first? Ashley? Appreciate you, Ashley. Yeah, it's the amount. Oh, whoops, excuse me. Skylar was first. Sorry about that. Skylar was first there. Yep, it is the amount that you're trying to achieve or accomplish. So we're trying to get to 150 miles. Yes or no before I continue? Everybody can see that? Again, the reason that 150 miles is the distance is because that's the amount that we're trying to achieve. That's the goal, exactly. Sweet. So we have that there, distance equals 150 miles. And now up next, what we're going to do is we're going to go ahead now and look at the rest of the problem and see what information we can use here to our advantage. So let's go ahead and try that out now. We see that we have two cars, start from the same spot, drive away from each other in opposite directions. So everybody from right there, we see that we have one car over here, 25 miles an hour. Other car, 35 miles an hour. So we have multiple rates. What should we do with these rates, everybody? Right, exactly. We're going to add these rates. Exactly. We're going to add these rates because, again, they're going in opposite directions. If I take one step this way and two steps this way, that's 3 total steps. 1, 2, and 3. So you have to count them together here. So the opposite directions, we have rates. So we have rate 1. That's going to be 25 miles per hour. We have rate 2. And that is 35 miles per hour. So because it is opposite directions, we are going to add. Opposite directions means we take these and we will add them. And so the real rate is going to be 25 plus 35. Everybody, what's 25 plus 35? Help me out, man. Help me out. What's 25 plus 35? That is 60. That's correct. Appreciate y'all. 60 miles per hour. That is our true rate. Before I continue, again, does everybody understand how we got that 60? Not just saying, oh yeah, we added 25 and 35, that's how you got 60. No. What I'm saying is, do you understand why we got 60? That's what I want to know. Do you understand why we got 60? Okay, I see some no's, and that's okay. Appreciate you being honest there. I appreciate the honesty. Thank you for being honest. Yes, thank you. There we go. Cool. Here's the reason why. And this is how I want you to talk about it. Obviously, fitting in your own words and terminology in there if you want to. But long story short, the reason why we got this 60 right over here is because we have two objects in this problem. Look at the top over there. Two cars going in opposite directions. Opposite directions. Because these cars are going in opposite directions, you are going to add their distances together. Because again, it says how long will it be until they're 150 miles apart? If this car goes 1 mile and this car goes 1 mile, they're 2 miles apart. You add them together. They're covering new ground. So because you're seeing it that way, the cars are going in different directions, covering different distances, you add those rates together. And that's why we got 60. Yes or no, does that make sense, everybody? Tori, that's correct. Yes, if they start talking about objects going in opposite directions, you know that you're going to have to add some rates or add distances. Yeah, absolutely. So there we are. With that said, we are going to be looking for that time. So let me just put T for time, T hours or whatever. Let me actually just use black so it stands out a little more. Let's go ahead and get to it here. My distance is 150. So my distance, 150. Let me use green over here actually to color coordinate this. Then my rate, what's my rate going to be again, everybody? What was that again? That's going to be 60 for sure. That's going to be 60 right there. And then we have T for time, so 60 T. So allow me to take this right over here. And we're going to solve this thing. Everybody, how are we going to solve this? How do we solve for T right over there? How do we solve for T? Yeah, we're going to have to divide. Divide what? Divide what? Divide the C's? What? Divide by 60 on both sides. Appreciate you. I don't know who said that because the chat went by so fast, but divide by 60 on both sides. Let's not get lazy here. There it is. Divide by 60. There we go. Cool. So with that said, booyah, 150 divided by 60. It's not as hard as you think because you have zeros over there. You have 150 and you have 60, both ending in zeros. So this is literally the same thing as saying 15 divided by 6. And if you need to, let's go ahead and do some long division here. 6 going into 15. So 6 goes into 1, 0 times. 6 goes into 15, 2 times. Subtract 12. You get 3. Lower the 0. So we have 6 into 30. Everybody, 6 goes into 30 how many times? 5 times. And so, yep, that would be 2.5. So everybody, the answer is going to be T equals 2.5 what? 2.5 what? 2.5 what? Thank you, Muhammad. 2.5 hours. 2.5 hours. And so everybody, what does that represent? 2.5 hours. What does that represent? What does 2.5 hours represent? And not just as a time, I mean, in terms of the problem. Yes, it's the answer, of course, but what does the answer mean? What does 2.5 hours represent in the grand scheme of this problem? Joshua, how long it took to do what? Very close. How long it took to do what? Exactly, Latifa, exactly. 2.5 hours is the amount of time it took to get 150 miles apart. Remember the question? It says, how long will it be until the cars are 150 miles apart? So it's going to take 2.5 hours for the cars to become 150 miles apart. Right there. Right there. So yes or no, everybody? Are we seeing that we're making a little bit to a lot of progress here? Are we feeling like we can understand this a little more? Opposite directions, add those rates. Same directions, we are going to go ahead and subtract those rates. Right, we're getting there slowly but surely. Krishan, make sure to understand that you need to say, hey, where did I get stuck at? Was it again? Knowing to see that opposite means add those rates. Was it knowing that it's a rate to begin with? Again, ask those questions there. Let's try this next one here. So I'm going to zoom in just a little bit right there. And I'm going to give you all the opportunity to try this one out here. So I'm going to give you a timer of about 1 minute, 30 seconds. And I want you all not to try to solve this in that amount of time. I want you to take the 1 minute and 30 seconds to just see what you notice about the problem. What can you kind of muster up in 1 minute, 30 seconds? It's all good, Brian. Take your time, man. Again, I just want to know if you guys can point out anything that you observe here. What are you observing here? What can you see? I'll give you the minute here to think about it. Start with the question, take your information down. It's all good. Hey, hope you're enjoying the session recording so far. So as always, if you're looking for extra ASVAB help and support from a coach to kind of guide you through the process, study planning, and all the materials you need, just shoot me a text real quick. Again, I'm Coach Anderson, 567-698-8867. Go ahead and ask me about my All-Access program, or just ask me about the program in general. I'll be more than happy to tell you about it so you know that you can stress less and raise your score with ease. Again, I'm Coach Anderson. That's Ace the ASVAB. Text me now, and then let's keep going. So what we want to know first is how far apart will the cars be after 7 hours? So help me out, everybody. How far apart? What does that refer to? What do you recognize that as? Like, what do you think that refers to? So that's going to be a distance. Yeah, that's going to be a distance. Because again, how far apart? Think about it. How far apart are you and your neighbor? Okay, about 80 feet. His house is right there. Okay, how far apart are the United States and South Africa? Okay, a couple thousand miles. Okay, cool. So think about it. How far apart? If you ever get confused there, kind of just think about scenarios here and think about what that sounds like, whether it's a distance, a rate, or a time. That's always going to be a good idea there. So how far apart, that is a distance. Distance equals blank. You look at the answers. Answers tell you miles. Again, you look at the answers. The answers all say miles, so we know that my answer is going to be miles. And then from there, everybody, what else did we get from highlights here? What else is highlighted that we should write down? What else is highlighted that we should write down? What should we write down? 7 hours. There we go. Good. And 7 hours, what kind of a unit is that, everybody? Time, correct? Nice and easy. We have time equals 7 hours, so write that down nice and easy. Next, we're going to go ahead and take down the information from the problem now and see what we can do with that. So here, 2 cars start at the same place and drive in the same direction. Oh, that's pretty interesting. 2 cars, same place, same direction. Okay. 1 car drives at 50 miles per hour, other car 40 miles an hour. So we have 2 cars driving in the same direction. If we're going to go ahead and kind of highlight this, allow me to go ahead and take my drawings from earlier. And so we're going to go and visualize this. We're going to visualize this. If 1 car goes 50 miles per hour, and the other one goes 40 miles an hour, and they're going in the same direction, everybody, what should we do? What's up, Tony? What should we do with these 2 rates? What should we do? What should we do while I pet my non-existent beard? What should we do? We should subtract. Exactly. We should subtract. We should subtract because, again, remember, everybody, I want to make sure we see this nice and clear. Got to make sure we see this nice and clear. So look right here. And then look where this ends up. This right there, this dead zone doesn't count because look, your car ends up right here and then your other car ends up right there. So you're only counting the distance right here to here. This is all you care about. That's all you care about. And because that's all you care about, again, this over here needs to get canceled. That part needs to get canceled. And that's why you subtract. That's exactly why we subtract the rates. So with the rates here, same direction. Just make sure we see that there. Same direction. So the rates here are going to be 50 miles per hour minus 40 miles per hour. Everybody, hardest question of the day. What's that going to be? Right, that's going to be 10 miles per hour. That's 10 miles per hour. That's our rate. That is our true rate. So with that said, let's go and solve this here. We're looking for distance. We're looking for distance. It's d miles. So I'll go ahead and set this up. Distance equals rate times time. The distance that we're looking for is equal to the 10 miles per hour multiplied by 7 hours. Everybody, what's that distance going to be? Yep, Krishan, same direction, you subtract. Yep. So it here is 70 miles. There's our answer right there. We are feeling pretty good about that. The answer here is A. So now that we've had the chance to go through an example of, again, a same direction and an opposite direction problem, everybody, are you feeling like you're better able to spot whether it's subtracting or adding rates? Cool. So there's a lot more yeses than there were nos before, and I like that. Obviously, not everybody's there yet, and that's okay. Remember, it takes time. It takes time. You can't just give up the first moment that it's not working out. We have to, again, be able to ask the right types of questions. Okay, so what did I get? Okay, where am I stuck? You know, what part of the problem am I looking at this like, just don't know what to do? So if you can get to those moments, then you can ask those really good questions to make sure that you can grow. So one more time, just to recap this for everybody here, pay attention. So the problem here asks us to find how far apart. That's distance. So we're looking for distance. They give us 7 hours. That's time. I noticed that we have two rates, 50 miles an hour and 40 miles an hour. What do we do with them? This is your key. Two cars, same place, same direction. The same direction tells me that, again, you have this scenario right here. So the 50 and the 40, you subtract them. Same direction means subtract. We got 10 miles per hour. To get the 70, all we did was plug and chug. D equals RT. The distance that we're looking for is the rate, the 10 hours, or excuse me, 10 miles per hour, 7 hours, multiply 10 times 7, and you're done. And you're done. And so I want you guys to try this one out. Right on, Shamari. I'm glad you are. So I want you guys to try this next one out. I want to see if y'all can at least set the equation up. So remember, if you're starting to get it, that's great. That means you got one problem right. Now, can we repeat that success? So again, I'm going to give you a minute, 30 seconds, not to do the whole problem. I'm not asking you to do the whole problem. I'm only asking you to take notes real quick on what you noticed about the situation. What do you notice? What do you think you can use here to help you out? Go ahead. Go ahead. Let's get this. Hey, Brian, it takes time. Brian, it takes time, man. It's not going to be we can't look for that instant gratification. Math is delayed gratification. You have to practice to the point where, you can perform without thinking. That's really the point you want to get to, where you're not hesitating anymore because you know what to do. We got about 10 seconds here. Again, defend your answer here. Go ahead and give me a reason why you made the decision you made. If you're going to give an answer, but give a reason. If you just have a setup, hey, set it up for me. Tell me what you noticed. If you noticed that, oh, there's only one word that I noticed here, and that's same or opposite. Again, it's all good. It's all good. Go ahead, give that up, give that up. Time's up, time's up, time's up. Go ahead. Show me, show me, show me, show me, show me. What do we have? What do we have? Come on. Since both is going east here, we have two rates, and this will be 500 minus 400 equals 100. And you have, uh-oh, not quite, boss, not quite. Not quite, Mohammed. All right, let's see what we got here. So it says that they're going in the same distance at the end, but the others are not. Okay, never mind, I was confused. Okay, I'm a little lost. I got confused. I'm lost. I just know where to start. That's good, right? If you know where to start, then we can keep working with that. That's always a good thing. That's always a good thing. So let's go ahead here and let's get the job done. Let's see what we can do. So first things first, everybody. What's the first thing we need to do in any word problem at all? Just as a quick refresher. What do we always need to do? Read the question, right? No matter what, we need to read the question. So let's go ahead and ask ourselves right over here. How long will it take for the jet to catch up to the plane? Sounds good. So let's go ahead and highlight that the right way. How long will it take? So everybody, how long will it take? When it comes to that phrase there, how long will it take? That's a distance, right? It is not a distance. It is a time. It is a time. It is a time. So this is something I'm going to do very often, okay? I want to make sure that you're not just agreeing with me, at every sense of the word. I want you to really question what you're learning. I never want to get to the point as a teacher where I feel like I'm just teaching you how to memorize. That's the worst way to get through the ASVAB. I'm telling you that right now. If you want to pass the ASVAB convincingly and confidently, memorization is the very first thing you should do, not the only thing you should do. Okay. So with that, we're looking for time. How long will it take? We want time. Time equals blank. Everybody blank what? Seconds, minutes, hours, days to weeks, months, years. What is this? Hours. That's right. Time equals blank hours. Booyah. Okay, here we go. Now let's go through the information here. A jet takes off from an airport and heads east at an average speed of 500 miles per hour. Okay, cool. So we see here that we have a jet. Let me use a different color here. So we have a jet takes off, heads east, speed 500 miles per hour. Sounds good. So we have a jet eastbound. And then the rate, or is that a rate, everybody? Is 500 miles per hour? Is that a rate? Is that a rate? What gives it away? How do you know? How do you know that's a rate? Yeah, the word per. The word per gives it away. Again, miles per hour. Miles by itself is a distance. Hours by itself is time. Miles per hour is a rate. So the rate here is 500 miles per hour. Up next, let's go ahead and take care of what we see next. We see that there is a plane 400 miles east of the jet traveling at an average speed of 420 miles per hour in the same direction. So right here, there is a plane 400 miles east of the jet. Sounds good. So we have a plane. It is also headed east. But we have 400 miles away. Everybody, what kind of a unit is that? Is that a rate? Is that 400 miles per hour? Is that 400 hours? Is that 400 miles? What is that? That's a distance. That is absolutely a distance. That is a distance. Because again, 400 miles. It's just miles. It's just miles. So for sure, that's going to be a distance. Now let's go ahead and take a look at what we have next. Average speed of 420 miles per hour in the same direction. Sounds good. So 420 miles in the same direction. So I'm going to write that down as well. Same direction. So we have another rate here. 420 miles per hour. And then we see again the big phrase right there. Same direction. Everybody, if you look at your notes, what does it tell you to do if we have the same direction? What do we end up doing? Correct. We end up subtracting the rates or subtracting the distance. Either way, but that's what's happening. Because again, you're covering the same ground. You're covering the same. And so when that happens, you have to subtract what is covered by both. So again, what we're going to do here, we have the rate here, 500. I'm going to grab the highlighter here. So 500 miles per hour, 420 miles per hour. Those two rates we will subtract because we see same direction. So there we are, 500 minus 420. Everybody equals what? 80 miles per hour. So this is your true rate. Or you can say your relative rate. That's what you would call that, the relative rate of catch up, or the catch up speed, you might want to call that too, or the catch up rate. You're going to see that said a million different ways. But this is where I know a lot of folks here got stuck. So let's just take a pause for a brief moment. Let me lean back in the chair. Let me just ask y'all real quick. Do you understand? Not how we got the 80, but why we got 80 miles an hour. Yes or no? Do you understand why we got 80 miles an hour? Again, same direction means subtract. We have two rates, 500 and 420. Subtract those, we get 80. Yeah, no worries, Ashley, for sure. Again, the reason why we got 80 is because we have two planes going in the same direction. And so when they're going in the same direction, the distances that they cover, a lot of it is going to be the same. And so we have to subtract what they both cover. So that way we only think about how far apart the plane is to the other plane. Not the starting point to the ending point, but how far apart the planes are. Cool. Cool. So again, just to kind of illustrate it again, if we have two people and we say that this person goes 1, 2, 3 steps every minute, and this person goes 1 step every minute, again, this first step that they both took, you don't count that. You only see that they are 1, 2 steps apart. 2 steps apart. That's all you see. And I can prove it to you by going ahead and just grabbing this and moving it right up there. They took that same step. And so again, we would cancel that out, leaving those two right there. So with that, booyah, we have the true rate right there. We have a distance right here, and we're looking for time. So all we have to do is set it up, solve, and we're done. So with that said, here we go. D equals RT. And now we'll go ahead and set it up. 400 right over here. 400 miles is what we were given. The rate is 80 miles per hour. And we're looking for time. We're looking for T hours. So I'll just put 80T. Everybody, what's the last thing we need to do here to solve this? Divide by 80 on both sides. Appreciate y'all not getting lazy there. Appreciate that. There we go. Divide by 80 on both sides. Let's do that right there. And we are good. Booyah, booyah. Cancels on the right side. And we get T equals what, everybody? 5 what? 5 hours. 5 hours. 5 hours is how long it'll take for the jet to catch up to the plane. 5 hours is how long the plane will take to catch up, or the jet will take to catch up to the plane. Let me go ahead and get rid of this right here. Boom. Princess, D equals R times T. Yeah. I mean, appreciate that. I got you. Don't worry about it. Dylan, bro, why? I'm not sure what the Y was for. Tyree, you absolutely do have to read. Everybody on the ASVAB, there's no excuses for misreading something. You know that you have to be meticulous about it. You got to be detailed. You got to be detail oriented. You know, there's a very big difference between miles and miles per hour. Very big difference. There's a very big difference between opposite directions and same direction. You know, you don't want to get got. You don't want to get confused or roped in when at the end of the day, you know, if we prepare properly, there's plenty of things in the ASVAB that test anxiety won't affect. And so the more you practice and the more you confirm and the more you talk about what you're doing, the more likely it is that when you take the test for real, you're not second guessing yourself. Because you know, I've talked about this through and through. I've talked about this for the last 5 weeks. I know exactly what I'm talking about. That says opposite directions. I'm going to add those rates. You know, you want to speak about it with confidence. Like you almost want to get annoyed with yourself. You want to go to the point where test anxiety really, really, really affects you from doing your best. You want to go from there to in the middle where it's like you're confident, you know what you're doing. Test anxiety is still kind of there, but when it does creep in, you almost get angry. And you're like, I know what I'm doing. Stop. You want to go from there to then automaticity, where there is no voice going on, no second guessing. It's recognition, immediate recognition. Oh, I see opposite directions and I see 2 rates. Your mind already starts adding the rates for you. That's the point you want to get to. So again, from that frustrating failing with test anxiety to getting annoyed with your test anxiety because your confidence is taking over, to being whole 100% confident. That's the point you want to work toward. So with that said, let's go ahead. The reason we didn't multiply was because we didn't know what T was. So we're looking for T. 80T, we technically are multiplying 80 times T. To get the answer, you have to divide and do the opposite on both sides here to get rid of the 80. Yeah, you got to divide the 80. Yeah, let's go ahead. Practice time, 3 minutes per question. So remember, start off with what you want. Everybody, what does that refer to? What do you want? What does that refer to? That's right. Read the question. What do you want? You want to read the question first. Read the question. Everybody, what do you have? What does that refer to? The information. That's right. Write down the information. That's the information. And then lastly, what's the connection? That is where you're setting up your formula. So I went ahead and revealed that to you nice and easy, but that is your formula, setting it up the right way. So I'm going to give everybody here 3 minutes per question. The first 2 minutes, this is where we are really going to be focusing on, again, setting it up. The last minute, that's what's going to be taken for calculating. So what we're going to do is the first 2 or 3, we'll do them one by one. And then after that, I'm going to see if we can do maybe 2, 3, or 4 at a time, back to back to back, and we'll go over them all individually. So let me get the timer back up. We will get the party started here. So there's 3 minutes. Let me mark that down. Perfect. So timer is started, and let's have a party. So first things first, really the main question is, do you understand the question? Do you understand the question? 2, we're able to write down the numbers and meaning. Numbers and meaning. Beyond that, do you understand the keywords or phrases? So keywords and phrases. From there, can you set up the formula? Is your distance, rate, time problem set up? And then 5, did you calculate quickly? and confidently. So right there, these are the 5 like real soft steps that I would say that you really need to get through. So everybody, I want to give everybody a chance here, yes or no. And I want everybody to answer, even if you didn't get to that step. If you didn't get to the step, just say no. So everybody, step 1, was everybody here able to identify the question of the problem? Yes or no? Was everybody able to identify the question where it says, how long will it take? Right there, to know that that means time. Time equals blank hours. Was everybody able to understand that part of the problem? So that was part 1. That was the question. That was the question. Sweet. Next, what we need to do now is understand the numbers and meaning. So let's go ahead and take a look here. That's where we are. The numbers and the meaning. What is this all about? And I keep seeing it typed privately into the chat box, and I kept ignoring you. So quick pause, everybody. Again, if you don't have enough time to sit through the whole class, but you are interested in the full program and you want to learn more about it, I don't want it to take away too much from the class right now. But if you look right here at the bottom left of every slide, you'll see the full program link. So just go to asvab.info/classes. I'm just going to put this right here. If you use this code, that will give you a nice little discount there. So I know you have to go. I'm not going to say your name out loud because you're private here. But again, I'll talk about the program at the end of class. Okay. So hopefully you can stay to the end. But here we are, the numbers and the meaning. So we have 2 boats 120 kilometers from each other. So we grab that right there. So everybody, 120 kilometers from each other. What does that represent? That represents a distance. That represents a distance. And so we'll write that down. Distance equals 120 kilometers. Sounds good. No worries. All right, up next, it says they're headed toward each other to exchange cargo. One boat sails at 15 kilometers per hour. Okay, cool. So I'll write that down. 15 kilometers per hour. Other sails 25 kilometers per hour. So we know that boat 1, the rate, because it says 15 kilometers per hour, so 15 kilometers per hour. And then boat 2, that rate is 25 kilometers per hour. Okay. We'll write that down there. Sounds good. All right, cool. So those are all of our numbers. Great. So was everybody able to write that down? Was everybody able to determine that the 120 was distance, the 15 and 25 are both rates? Yes or no? Were we able to get to that point in the problem? So notice this is the progression here, right? This is the progression we want to go through. The question, do we understand it? Next, the numbers, do we understand them? Because anybody can read 120. Anybody can read 15. Almost everybody can read 25. So if you look at that, well, can you define what it means? That's the next step. So boom, if you were able to get through that, then you've successfully done the second step of the problem. Step 3, the keywords and phrases. Everybody, what are some keywords and phrases that are important in this problem? Where do you see opposite directions? Toward each other. There you go. Toward each other. They're going toward each other right there. Yep. So right here are headed toward each other. So what does that mean, everybody? Let's go ahead and draw the C's. So let me give me a nice C-like blue. That was obviously horrible. And that's horrible. We'll just do something like that. Something softer there. And so then we have this boat over here saying, hey, I'm going to go ahead and head towards you. And then we have this boat over here saying, hey, I'm going to go ahead and head toward you, even though I'm smaller. So everybody, what should we do with these rates? If these boats are headed toward each other, what is that considered? Toward each other? Is that opposite direction, same direction? If they're heading toward each other, is that same direction? Nah, it's opposite. Yeah, it is opposite. They are going in opposite directions. Again, think of it like this. If you have one boat facing this way, the other one facing this way, well, what happens after they pass each other? Well, then in that case, they're heading in opposite directions now. They're heading in opposite directions. So that's what they are. That's what they have been doing the entire time. They have been heading in opposite directions the entire time. So again, toward each other means opposite directions. So if you need to write that down, please do. So toward each other means opposite direction. Means opposite directions. Right there. Means opposite directions. So Krishan, if you're confused in terms of connecting, same direction means subtract, opposite means add, well, then you just got to practice that, my dude. You got to make sure you practice that. Whether it's recitation, so reciting it over and over. So opposite directions, if they're driving away or heading toward, you add. All right, so if they're going in the same direction, if I'm catching up, remember that I'm canceling out what they've both done. Subtract if they're going in the same direction. You just got to give it the time. Yeah, you got to give it the time to remember it, to memorize it. So cool. With that, here we go. Let's go and fill it in now. We want to add. So toward each other means opposite directions. And remember, that means add. Add right there. So let me get rid of this right here. Okay, so let's finish this off. So distance equals rate times time. Everybody, what am I filling in for distance? What am I filling in for distance? 120 right there. Yep. 120. Then we have the rate, which is what? Oh, we got to add the rates. So we have 15 plus 25 is equal to what? 15 plus 25 equals 40. That is correct. Right, to kilometers per hour. Right there. And then we don't know what the time is. It's just T hours, so 40 T. So everybody, what are we going to do to solve this now? What are we going to do to solve this? Be specific. Because now we have the keywords and phrases all locked down, so that's good. But now what we're doing is we're setting up the distance equals rate times time, which is what we did. And now we need to calculate effectively. So now we need to get rid of the 40 because we're trying to get the T by itself. So to get the T by itself, we will divide both sides by 40. And then we are done. So right here, booyah, we cancel out. And now we have 12 divided by 4, which will be 3. 3 equals T. So the answer is what? 3 hours. Booyah. Nice with the mental math, Joshua. Appreciate that. Nice. So how are we feeling about this one, my party people? Who's feeling pretty good? Who's feeling like, yo, okay, maybe I don't have to leave this Monday night class feeling like a bigger failure than a lot of these. I'm not even going to say some names. But yeah, I was going to say some celebrity names, but yeah. You can get lasers. You can get the whole, I don't know, whatever sound you want. Whatever you want, guys, whatever you want. As long as you're feeling good about it, I am happy. So there you go. Hey, it does. I'm glad to see it. Starting to feel refreshed, Tori. That's pretty good. Love hearing it. Again, it's all about the why. It is all about the why. So as a recap again, because they were going in the same direction, we were going to add those rates because this ground and this ground, these are new grounds. And so we add it together to get the totality of everything. All right. So with that, David, stay till the end. I want to hear that. So with that, let's go to the next one here. Now, this is going to be a little different, everybody. This is going to be a little different. I'm going to give you the full 3 minutes again, but I want to see if you can understand why this one is different than the other one. So this one got slightly, and I only mean slightly, like slightly harder, but I want to see if you notice what the difference is between this one and the other ones. Remember, if you're going in the same direction at the same time, opposite direction at the same time, you add or subtract. But what if it's not at the same time? You got to figure out what's going on here. So figure that out. I read the question and I'm going to go straight to it, straight to the question. So I see the question here. After traveling for 4 hours, Leah finally caught up. Find Suma Lee's average speed. So I'm going to highlight there, Suma Lee's average speed. So I'm going to write that down. I want Suma Lee's speed. All right, and that's going to be miles per hour. So blank, I'll just say R for rate, miles per hour. Sounds good. Now I'm going to grab all the other numbers. So Suma Lee left the airport and traveled toward the ferry office. 1 hour later, Leah left traveling 80 miles an hour in order to catch up. After traveling for 4 hours, Leah finally caught up. Okay, that was a lot, but what I ended up seeing was this. So Suma Lee, there she is, traveled toward the ferry office. And then an hour later, Leah left traveling 80 miles an hour. So here we go. Leah leaves 1 hour later, 80 miles per hour. And then it says 4 hours, she caught up. Caught up after 4 hours. Okay, so when looking at all of this, what I'm looking for is Suma Lee's speed, not Leah's speed. I want Suma Lee's speed. So what I need to get Suma Lee's speed is Suma Lee's distance and Suma Lee's time. That's what I'm going to need. I need Suma Lee's distance and time to get Suma Lee's rate. So what do I know? I know that Suma Lee was going for an hour, and then 4 hours later, so that's 5 hours. That's 5 hours right there. What's the distance? Well, Leah's going to tell me the distance because Leah caught up after 4 hours going 80 miles an hour. So Leah, I'm going to solve this one here. Distance equals 80 times 4. Distance is going to equal 320. I'm going to get rid of that timer. So Leah went 320 miles, and that's exactly how long she went to get to Suma Lee. So from there, what I'm going to do is I'm going to go ahead and set it up. Distance equals rate times time. Rate, distance, time. 320 equals 5 times R or R times 5. Either way doesn't matter. Divide both sides by 5. And I have my answer. That's going to be, cancels out. That's going to end up being 64 miles per hour. And that's going to be my answer, D. And so that was real time. So if you, and trust me, like that took about what, like maybe I slowed it down a little bit, but that still took about 1.5 minutes, 2 minutes-ish. And that's what you're looking for. That's what you're looking for on the test, you know, about 1.5 minutes, 2 minutes per question. But I'm going to go back and I'm going to do this whole problem again. So don't worry if you were confused at all. But what we need to understand is that you cannot trust yourself to be confident if you haven't done it before in practice. I'm going to say that one more time. You can't trust yourself to not get anxious on the test if you haven't shown the confidence in practice. You have to exhibit that confidence. Notice how I was talking as I was doing. That's the main focus of what I just went through right there, to show you that you can talk about the problem in real time. And notice I didn't fixate on the numbers. I fixated on what the numbers meant. And so yes or no, everybody, can anybody here appreciate what I just did there and kind of sees the direction that they want to go in what they're studying? Okay, great. Yeah, I really want y'all to get to, yeah, for sure. Yeah, for sure, Tori. I got you. I got you for sure, Tori. But I really do want to make sure that y'all can at least see the point of that, so it's not a waste of time. So I'm going to go ahead and do it all over again. The way that I got the 5 hours is because Suma Lee, when you're talking about Suma Lee's time, Suma Lee was already driving for an hour. Then Leah tried to catch up to her. And then Leah drove for 4 hours. So Suma Lee was driving 1 hour, and then it took 4 extra hours to get caught up to. So that's where we get the 5 hours. So let me go ahead and copy and paste this and do it all over for y'all. I got y'all. So here we go. Let's start right over here. I'm going to go slightly faster in terms of the explanation because there's some of these things that you guys already know. But let me go ahead and just do it like this. You got Suma Lee and you have Leah. Everybody, yes or no? Can we agree that there are two people in this problem, Suma Lee and Leah? Great. Sounds good. So with that said, let's go ahead now and take the information down. We want Suma Lee's average speed. So everybody, that's the same thing as saying Suma Lee's rate. That's what we want. Blank miles per hour. I'm just going to put R for rate. Up next, what else do we have? It says Suma Lee left the airport, went toward the ferry. Here it says 1 hour later, Leah left traveling 80 miles an hour. So look right here. Leah, her rate is 80 miles an hour right here in an effort to catch up to Suma Lee. After traveling for 4 hours, Leah caught up. So everybody, yes or no, is it safe to say that Leah's time driving is 4 hours, not 5? Suma Lee's is 5 because Suma Lee, again, drove for 1 hour and then Leah drove 4 hours. But Leah only drove 4 hours. Suma Lee was the one that drove the extra hour from the very beginning before Leah started driving. So Suma Lee had a 1 hour head start, basically. So that's why Suma Lee is 1 hour plus 4 hours equals 5 hours of time. That's the point I really want to make sure y'all understand. The differences between Leah and Suma Lee's time. Cool. Glad y'all see that. Sweet. Now from there, we are going to see that, hey, I can't solve for Suma Lee's rate. So let's just focus on Suma Lee for a moment, everybody. Do y'all notice that if you're trying to solve for Suma Lee's rate and you only have Suma Lee's time, but not the distance, do y'all see that this is impossible to do? You can't set up a distance rate time problem and be like, all right, cool. I'm looking for distance. I'm looking for rate, but I got 5 for the hours. You can't solve that. Right? You cannot solve that. You need only one variable. If you got 2 of them right there, like the D and the R there, not going to work. Not going to work. And so that's the hint that gave me, or that's the part of the problem where it looks like it feels like I got stuck, but getting stuck really turns into a question. Getting stuck went from, yo, I can't solve this because I don't have the distance. But hold up. Can Suma Lee tell me the distance? Can Leah tell me the distance? Because remember, Leah caught up. Leah drove for 4 hours from the same spot that Suma Lee started from, drove for 4 hours at 80 miles an hour and caught up. Do we have the ingredients here to figure out the distance, everybody? Do we have the ingredients here? Having the rate and the time, can we get the distance? Yeah, that's how the distance rate time formula is spelled. Absolutely. Absolutely. And so I'm able to say, hey, the distance here is going to be equal to the rate times the time. And everybody, what will that be? Yeah, Leah just got an oil change for sure. So that 80 times 4, that's going to be 320 there. Yep, 320 miles. And so with that said, that's the same distance from over here. Let me go ahead and get rid of this. That's the same distance here as it is here. Does everybody understand that? They went the same distance. They did it in different times, but they went the same distance. That's the biggest key there. That's the biggest key. And so now we're good to go. Now we can say that we got our distance, rate, and time. And now we can be done. D equals R times T. Plug in 320 for the distance. Plug in the 5 hours for time. And so that'll just be 5 times R. And so the last thing that you'll do is divide both sides by 5, and you're good. cancel that out, and then you do your long division. 64 miles per hour is your rate for who again? 64 miles per hour for who? Leah, right? Nah, for Suma Lee. That's right. For Suma Lee. Boom. And that is Suma Lee's rate. So did anybody here enjoy this problem, even though they got it wrong or right? Anybody here enjoy it? Yeah, for sure. So Raymond had the same question as Ashley. So I got y'all. So the question was again, okay, so how did we get 5 hours for Suma Lee? Like, how did that happen? Great question again. So just turn your attention over here. So think of it like this. Think about the start of the problem as 0 hours, right? So everybody put your pencils down. So the start of the problem is 0 hours. So let's read along here. Don't worry about the numbers, just worry about the situation. So Suma Lee is leaving the airport right now, okay? So Suma Lee leaves the airport to go to the ferry. I don't know where she's going. I don't care where she's going, but she's traveling somewhere. She leaves from the airport. Sounds good. Still 0 time. She's just left. Next, 1 hour later, in reference to when Suma Lee started, Suma Lee has now been driving for 1 hour. And after an hour, that's when her friend Leah starts driving to catch up. Maybe Leah's flight landed an hour later and got the rental car an hour later, right? Cool. I don't know. I don't care. But long story short, everybody, can we agree that when Leah leaves, Suma Lee has already been driving for an hour? Yes or no? Can we agree there? When Leah leaves to go catch up to Suma Lee has already been driving for 1 hour. So that's where the 1 hour comes in right here. But that is not Suma Lee's total time, because Leah drives for 4 hours, which means Suma Lee is also driving during those 4 hours. So again, Suma Lee drives, gets an hour head start, 1 hour head start, then 4 hours later after that gets caught up. So boom, 1 hour plus 4 hours, that's where the 5 hours comes in. So Raymond, great. Who else had that question again? Who was that? Ashley, do you get it now too? Let me know, Ashley. Because those are good questions. Like, why is it 5 there but 4 over there? You know, you got to ask those questions. I'm glad you two ladies did. Or not you two ladies, Jesus, sorry, Raymond. But I'm glad that you and Ashley, you and Raymond asked that question there. So with that, Raymond, that's on me, man. Sorry. So with that, cool. Glad it makes sense. I think we have a question here. Romeo, what's going on, boss?
Can you hear me?
Yep, I can hear you now.
Yeah, what I did, I know it is 5 hours, but what I did wrong, I add 5 hours times 80 and I get 400, and I divide it by the 5 and I get 80, and I said 80 is not there, so I guess I did something wrong. But what I saw you did, you add the 4 hours times the 80.
Yeah, and so the biggest thing here, Romeo, is that, and I'm sorry to cut you off here, but the biggest thing to understand is what the numbers are related to. What do they mean? Because I heard you earlier say that you did the 5 hours with the 80 miles per hour, but the 5 hours is Suma Lee's time. The 80 miles per hour is Leah's rate. So notice how we're talking about two different things. So when it comes to setting up your equations, you have to make sure that you're representing the same thing in those equations. So it works the same with proportions as it does for DRT problems. You got to know that the numbers that you're putting in a formula are part of the same situation for that formula. Got to make sure you have that there. So with that, I do want to ask, I'm going to give room for Tony, Young, and Takara very quickly because I want to give one more problem. And then we are going to wrap it up after this next challenge load question. So go ahead, Tony.
Oh, wait, question. Oh, yeah, I was so. Oh, I see you get 5 hours. That's why I get confused. Like, said one. Let's say 1 hour plus 4 hours equals 4 hours. I see you get add the hour. That's why it's like 1 hour later and 4 hours.
I know it's Tony.
I see. That's why I got a little confused. Like, I said, how we get the 5 hours coming from? That's why I got a little confused.
It can definitely be confusing, man. It can definitely be confusing. So I'm glad you saw that.
Yeah,
so let's go ahead and go with are you good there? Cool. Let's go ahead and go with Young there. What's going on, Young? And going with Takara. What's up, Takara? What's your question?
Hey, can you hear me?
Yeah.
Hey, so I guess I'm a bit confused or I'm slightly misunderstanding at some point. Correct me if I'm wrong. The rule is in the same direction you subtract, correct?
Correct.
Okay, and in opposite directions, if like one is coming towards each other, you add, correct?
Correct.
Okay, there was a question that we did earlier that was replica to this question, and we subtracted. When applying the rule, does it matter how and when we find a distance or rate or time? Does that rule apply?
Yes, it does matter.
Okay.
So that's a perfect question, Takara. I was waiting for something
Yeah,
to
because
happen.
I was so lost. I'm like, okay, I went while you was
Oh, you're
explaining to
good.
everybody else. I went back and I read that question. I went through the stuff. I said, we subtracted right here, but we added on this one. So I guess I'm misunderstanding something. I'm just like, okay, the rules clearly state earlier in the tutoring that in the same direction you add, but we subtracted right here.
Yeah, so pretty much the rule of thumb is yes, same direction, subtract, opposite directions, add. And that's if they're doing that at the same time from the same place. So
Okay.
what you noticed with those other questions was, oh, these trains are headed, or these boats are headed to each other at the same time, or they started from the same place and go in opposite directions, or same place and go in the same direction. And so they started at the same time. And so that's how you could blend in together the rates and the distances and time. But here you can't do that. Here it takes a different approach because notice Suma Lee starts first and then Leah leaves an hour later. And so the timing is different. The rates different, different scenarios because one is at this time and the other one is at this time. The only thing that was the same was the distance because they start and end in the same spot. And that's the only part right here and here. That's the only part that we could take advantage of. We couldn't actually blend everything together. We could only blend the distances as the same.
Gotcha.
So again, the reason was because it wasn't from the same place at the same time.
Totally understand. Thank you.
Gotcha. Hey, good question. So what we're going to do here, gang, is we're going to go over one more question here. I'm going to go ahead and put this on you, give you guys 2 minutes to try it out, and then I will give you the answer, and then we will call it a day. So with that, oh, man. So I'm going to, I don't want to give you that one. So what I'm going to do is I'm going to go ahead and give y'all this one, and then I'll give you another one here as a torture problem before y'all go. So go ahead, take a minute and a half of this one. This one's actually a little less torturesome. So let me go ahead and give y'all this one for a minute and a half. Thanks for going ahead and taking the time to raise your score. I know it's not easy. I know it's tough. I know you got a lot to work through, so I do appreciate you. I'm Coach Anderson, and if you wouldn't mind, please go ahead and subscribe to our channel. That way you can get updated as we continue posting daily, so you can continue getting the help and advice you deserve. So again, go ahead and subscribe to the channel. Let's keep rocking the ASVAB. So here what we have is 195 miles. They're going in opposite directions, so 15 miles per hour divided into 195. That should give us 10 plus 3, which is 13 hours. Answer is B for y'all right there.